Hello, class. It's Mr. Mormon. Welcome to this lesson on solids, liquids, and gases. Before we talk about solids, liquids, and gases, we need to get some general vocabulary down. Let's start by talking about matter. Matter is what everything in the universe is made of. That is matter is going to have mass and it's going to have volume. It's going to take up space. Now, matter is made up of atoms and molecules. Atoms can join together with chemical bonds to form larger structures called compounds and molecules. Now, molecules and compounds are actually very similar. The difference is molecules contain two or more atoms that are chemically bonded together. An example would be O2. That's the oxygen you're breathing in, or H2, which would be molecular hydrogen, or H2O, which is water. Whereas a compound has to contain two or more different atoms. So that O2 that we were just talking about, although it's a molecule, it's not a compound. Water, H2O, would be both a molecule and a compound because it contains two or more atoms and there are two or more different atoms. So H2O and CO2 are compounds. Okay, so now that we know some of the basic vocabulary, let's move on. Atoms and molecules are perpetually in motion. Perpetually means always. They never stop moving. Now, the more energy you give the matter, the more the atoms are going to start moving. That's the difference between something that is hot and something that is cold. A cold piece of steel versus a hot piece of steel. They might look the same, but if you could see the actual molecules that the steel is made up of, in the hot example, the molecules are going to be vibrating and moving much more. They have more energy. Now, the phase of a material, solid, liquid, or gas, is going to be determined by how much energy and motion the particles have. So let's compare the three different phases: solids, liquids, and gases. Let's start with solids. Here I've drawn the particles in a solid. They're close together, and they're going to be moving, but they're stuck in place, but they're still moving. They can't move past one another, but they are vibrating. Maybe I could draw that like this. Here I'm going to show little arrows showing that each one of these little particles is vibrating a little bit, moving in all different directions. Locked in place, but vibrating. So these arrows are going to be very short, showing vibration. Now here are some things that we can say about solids. They have a definite shape. They have a definite volume, which means that, a solid is going to hold its shape and its volume. Of all the three phases, this is the one with the lowest energy. The particles are stuck in place and vibrating, and the particles are going to be the closest together. Now, let's draw the particles in a liquid. Notice that the particles have all spread apart a little bit, and they are filling the bottom part of the container. Now, if I was to draw the motion of the liquids, I need to draw them flowing past one another. Maybe that would look something like this. Again, these arrows showing the motion of the molecules flowing past one another. Now, these are the things that we can say about a liquid. They have no definite shape. They're going to take the shape of their container. But they do have a definite volume. They do not expand when you change them from container to container. Or if you spill them out of the container, you still have the same volume. The particles are going to flow past one another, as we've shown with the arrows, and they're going to have more energy and be farther apart than in a solid. And that brings us to gases. Notice that the gases fill the entire container from top to bottom, and the particles are very far apart. If I was to draw in arrows to show the motion of these particles, it might look something like this. Okay, they're bouncing, they're moving very fast, they're bouncing off the sides of the container. They're also bouncing off of each other, moving super fast. And these are the things that we can say about gases. They do not have a definite shape. They're going to take the shape of their container. Nor do they have a definite volume. When they leave their container, they will expand to fill the entire area that they're put in. The particles are zipping in all directions, bouncing off of each other and the walls of their container. The particles in a gas have the most energy and are the farthest apart of any of the phases. Okay, let's wrap up with this idea. When you heat materials, in general, the atoms are going to gain energy and begin to move faster. This causes them to bang into each other more, and they all have to spread out. And the material is going to expand. So generally, when you heat materials, they're going to expand. So when you heat materials, they're going to expand. Now, when you cool a material, the exact opposite is going to happen. It is going to contract, which means to get smaller. Now, this expanding and contracting is also going to change the density of the material, which explains why, for example, when you heat air, all those molecules move apart a little bit and the air becomes less dense. That's why a hot air balloon rises. Okay, I think that's about it for this video. I hope you took down all these notes. If you have any questions, you can ask me in class tomorrow.